Here we have graphing the ideas of different formats of graphs. Now, notice that we don't have some sort of graph that looks like y equals x minus h squared, because that means it implies two of the same, plus some k value. That would be what we've been working with before, with a stretch in front. This implies that we have two of the identical brackets. Now they're different. But we remembered that when this stuff moves the graph left or right. So let's take a look at that first. Let's take a look at this one, because maybe it does something, in fact. It's pretty consistent. Then we plug in numbers here, or this tells us that perhaps that also suggests it does the same. So we can call this stuff interesting x values, by the way, because they kind of tell us stuff of interest. Interesting x values. Now when I look at this first bracket, x minus 5, I wonder what would make that interesting, or an x value that could make it interesting. It appears that when x equals 5, we get a 5 minus 5 in that bracket, which becomes 0. Now, it means that this is a 0 up here, and that will multiply this bracket by 0, thus crushing it, and therefore leaving you with plus 6. So it appears that when you plug in a negative 5 or a 5, you get the y value of 6. That's something of interest. Let me just use my eraser and get myself some clean thinking here. Okay. But not only do we have one bracket, we have another one here as well. We've got x plus 4. Well, this kind of suggests that it's going to move us to the left, or if we pick negative 4, that'll be adding 4, we get 0. So when x is negative 4, this bracket becomes 0. That will multiply this, and it will effectively 0 out the x terms. And what are we left with? 6. So it suggests that when we have negative 4, we get a 6. Let's take a look at what that could look like on a graph. Alright, let me just grab a little bit of a axis here. Black is always not terribly bad for an axis. Alright, let's just do some drawing. Okay, so it suggests that when x is 5, this is where I'm going to look at this, and then negative 4. Oh, okay. Negative 4 and 5 are kind of important. Somewhere between here, it doesn't have to be perfect, somewhere between here there's a 0, because it crosses over at 0 from positive to negative. It's not perfect here. Okay. So, lo and behold, now we said that when it's negative 4, it's 6. There. And at 5, it's also 6. Now, we know that when we multiply an x binomial by an x binomial, we get a quadratic, or a squared. So therefore, this thing should, without proof here, should in fact be a quadratic, and therefore a parabola-based shape. It appears that it's positive x, and we're going to get a positive x squared. That means this graph is heading up. So it looks like, and it's symmetrical about there. And so somehow we have an idea that this graph looks something like this. Now, it wasn't a video glitch, if you're wondering. I was just simply zooming in and zooming out. And I said, okay, let's get some more details about this graph, because we should be able to tell more about it. Here is one where we're going to look with a bit more details about what exactly is going on. Now, I just showcased that we have the idea of an interesting x value. It appears, for this one, that we have x, when I choose negative 8, That zeroes out the bracket, and I get -3. That's something important. When I look at these other interesting x values, when I choose a -4, it also means that this zeroes out, and that zeroes out, and we get a -3. Now we're going to see something about making a bit more details here. That should be good enough. I'm now going to draw a little bit of an axis here. We're on the left-hand side. There we go. That's all I really need for it to begin with, to draw x. And we're in the negatives. Oh well. So we have to consider -4, -8. Oh, and the graph's at -3. Let's just put a little y-axis at 0 somewhere here, not to scale. Doesn't really matter. There's a y-axis. That's when x equals 0. Okay. Now, I had to put -3. Okay. So, -4, the graph is at -3. Bam. And the graph is at -8. It's at -3. Okay. And we have a positive x times a positive x, which is going to lead us to an positive x squared. Therefore, the graph should be an upward-facing U-shaped graph of x squared. What I don't see is where it's going to fit down here. Let me just move up a little bit. Okay, since we have the same height, this is a very important thing I did not mention in the first one. Since we have the same height, this is a symmetrical graph, and we know by the idea of symmetry, somewhere, I'll put green here, somewhere between these two exactly the same heights, the graph is split directly in half. That can be found using these numbers. Well, there's 8 and 4, and it kind of suggests that precisely between them, between 8 and 4 itself, was exactly halfway. Well, you could literally go 8, -8 plus -4, -12, split that exactly in half, -6. So therefore, where this thing splits in half is at -6. And it appears if it's going up, it probably should be going connecting these guys. So it's somewhere down here. Okay. Now, the real interesting thing we want to know, well, where is it exactly down here? How do we do that? Okay, I'm just going to just zoom out a little bit. Well, we need our little version of our equation above. I'll rewrite it here, where we've got y equals x plus 8, x plus 4 minus 3. Well, this is an x value. We know that when x equals 6, it will kick us out a y value. So if we try putting in, -6, if we try putting in -6 plus 8, well, that's going to be 2. And if we put in -6 plus 4, that's going to be -2. 2 times 2, one's positive, one's negative, -4. And then subtract -3. -4 minus 3, -7. So now we know where exactly this location is. -7. And it's a point of interest. Voila, we now know where this thing is. This is the point, -6, -7. That is of supreme interest. The other part of supreme interest is this idea of this line of symmetry. And that is it for this introductory lesson.